Day 767 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3689, maximum total subarray value 1. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums of length n and an integer k. You need to choose exactly k non-empty subarrays nums L through R of nums. Subarrays may overlap and the exact same L and R can be chosen more than once. The value of a subarray is nums of L through R is defined as the maximum value of nums L through R minus the minimum of nums L through R. The total value is the sum of the values of all chosen subarrays. Return the maximum possible total value you can achieve. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 1, 3, 2, and k equals 2. The output is 4. Explanation says one optimal approach is, so we're going to choose nums 0 through 1. That's index 0 through 1, which is equal to 1 and 3, right? We're going to take this 1 and this 3. That's our first subarray. Now, k equals 2 lets us know we need 2 subarrays, right? It says we're going to choose exactly k non-empty subarrays. So, first let's go over subarray. It says a subarray is a contiguous non-empty sequence of elements within an array. So this might be a subarray, or this might be a subarray in this array right here, or this whole thing might be a subarray. But the numbers have to be contiguous, meaning they have to already be next to each other. We can't just pick this 1 and then there's 2, or just delete some and keep the same order. No, they have to be contiguous, meaning they have to be already lined up next to each other. So the first subarray we pick is 1 and 3, right? Boom, 1 and 3. 3 is the maximum value, so we do 3 minus 1, because remember, the total value is defined as the maximum value of L and R and minus the minimum value of L and R. In this case, L is 1, R is 3, so the maximum value is 3, minimum value is 1, 3 minus 1 equals 2. Boom, that's the first subarray. Then we're going to choose another subarray. This time we're going to choose nums 0 through 2. So this is 0, this is 2 right here. So we're going to choose this whole array is going to be our second subarray, right? 1, 3, 2, boom. Then the maximum value is still 3. So out of this subarray right here, 1, 3, 2, the maximum value is still 3, right? So we come over with 3, the minimum value is still 1, so 3 minus 1 is still equal to 2. Boom. Now we add up the values of these subarrays. This subarray has a value of 2, and this subarray has a value of 2. So when we add 2 plus 2, that equals 4, and that's how we got our answer of 4. Boom. So just in case that didn't make sense for y'all, though, let's go ahead and take a look at example 2. Example 2, we'll pick 3 subarrays this time. So in example 2, we have input nums equals an array of integers 4, 2, 5, 1, k equals 3. The output is 12. Explanation says one optimal approach is we're going to choose nums 0 through 3, 4, 2, 5, 1. So that's this whole subarray. Boom, we're going to choose this whole array for our first subarray. Boom. The maximum value is this 5. The minimum value is this 1, right? So we know 5 minus 1 is equal to 6. Equal to 4. Boom. Boom. Then for our second subarray, we're going to do 0 through 3 again. So remember, it says right here, we can, the exact same subarray, same L and R can be chosen more than once. So we are going to choose this subarray again, because remember, we want the maximum, we want to return the maximum possible value, total value that we can achieve. So to do that, we got to pick this array again, or one optimal way is we could pick this array again. So we're just going to pick 5 and 1 once again. Once we pick again, the minimum is 5. The maximum is 5. The minimum is 1. subtract, we get 4. And then finally, we're just going to do this subarray, right? We could have just picked this subarray the whole time, but we didn't. We didn't. Either way, the maximum and the minimum value would have been the same. But I guess for the sake of the explanation, they wanted just to show you that we can use the same subarray twice. And this is one optimal approach, not the only optimal approach. Anyway, I digress. The next subarray we're picking is 5 and 1. Boom. So we pick the 5 and 1. Same thing. The maximum is 5. Minimum is 1. So that's equal 4. When we do 4 plus 4 plus 4, that equals 12. And that is how we got our output of 12, y'all. So boom. I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, y'all. It's actually quite simple. Now, the first thing we want to do is we want to find both the minimum and maximum values in the array. And if the array is empty, then we'll return 0. So we'll just say, come over here and we'll say guard let bounds equal nums.min and max, put the parentheses, else we'll open up the brackets and we'll return 0. Boom. Now we need to calculate the difference between the largest and smallest values, and we'll multiply that difference by k and return the result. That's all we got to do, y'all. So we just say return, open up the parentheses, bounds.max minus bounds.min times k. That's all she wrote, y'all. Let's give it a run. Oh, I submitted it too fast. I should have ran it first, but that's okay because it still runs 0 milliseconds, beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.